Well, hello everybody, and welcome to today's webinar, Making Sense of Percents. Our presenter today is Sarah Lonberg-Lew. She is the treasurer for the Adult Numeracy Network. Please welcome her by saying hello in the chat box, letting us know where you're calling in from today. And with that, I will turn it over to Sarah. Thank you so much.
All right. Hello, everyone. Welcome. Thank you for introducing yourselves in the chat. I am going to be watching the chat today, so if you have something to say to me, questions, comments, please go ahead and put them in, and I'll do my best to keep up. Let me start my screen share here. Okay. So this is Making Sense of Percents, and my name is Sarah Lonberg-Lew, and I'm here with the Adult Numeracy Network. And if you're not familiar with the Adult Numeracy Network, we're a community of numeracy practitioners who support each other in bringing quality math and numeracy education to our learners. And if you're wondering why I keep saying numeracy and not just math, well, numeracy is an idea actually that can take a little while to get a handle on, and I'm hoping that through the conversation that we have today, you're going to develop some ideas about what is math and what is numeracy, how they're the same, how they're different, where they overlap, just through some of the explorations we do today. And our topic today is percents. And there are a lot of math topics that are important for adult learners. There's a lot of stuff that comes up on those tests that they have to take. And in my experience, this is one topic that every student comes in really wanting to learn about. And that's because it's not just that they're important for the test, but people know that percents are important in their regular, everyday adult life. When you're dealing with taxes, when you're dealing with discounts, when you're dealing with tips, when you're dealing with information that comes at you through the news, percents are around all the time. And when you don't know how to reason with them, it actually can be very frustrating and difficult. So our students generally do want to learn how to do percents, but even in spite of the fact that they are enthusiastic about it, it's still often been a source of struggle, even in math classes. So what I want to do today is I want to introduce you to a tool and a mindset for reasoning about percents that might change the way that students approach percent tasks on the test, but it also will hopefully help them reason flexibly and confidently about percents when they come up in real life. Because when percents come up in real life, it's not usually about trying to figure out to choose the one correct answer out of 4 or 5 answers. It's about things like estimating, making decisions, reasoning flexibly. And these things, reasoning flexibly and applying your understanding outside of the classroom to making decisions, that's part of numeracy. That's part of being a numerate adult. So to get started, I want to give you an example of a percent task. So I would like you to, I'm going to give you a few minutes to think about this. Put your ideas in the chat about how you might approach this task. If you want, you can put an answer, but I'm more interested in what your strategy is, what your approach is, even what your feelings are when you see something like this. So I'm seeing, I like to teach part-whole relationships, but it's tricky with percents because the part is really the whole in a percent problem. So it's hard to figure out what's what in a percent problem. You can change the percent to decimal and multiply. You can multiply by 0.7. You could find 10% and then multiply by 3 to get the amount off. we could estimate that that's about 1/3 off. Yeah, okay. So there's a lot of really great strategies here. A lot of flexibility in the way people are approaching this. I noticed that we're not all getting the same answer, and that's maybe because I didn't actually ask a question. So anybody who is giving me an answer is deciding on a question that they're answering, which is fine. That's great. I tend to leave off the questions because then I think it's more open. Students can take more approaches, and it tends to make them think more. So yeah, okay. So a lot of different approaches. What I found, my own experience, and what I've seen from a lot of my students coming in is that the folks who really panic when they see percents, the folks who really struggle, have been taught a sort of an approach that is there are 3 kinds of percent problems, and the first thing to do is to figure out which kind of percent problem you're doing, and then you're going to apply one of 3 procedures depending on what type of problem it is. So I love it. Keep them coming. You got a lot of great strategies coming in. But what I'm going to do is I'm going to just quickly go through these 3 procedures. This kind of traditional approach that you have to percents. One is to find the percent of a number, convert the percent to a decimal, and multiply that decimal by the whole. Second procedure, to find what percent one number is of another, divide the part by the whole, convert that decimal to a percent. And finally, to find the whole when you know the part and the percent, convert the percent to a decimal and divide the part by that decimal. So you could see, I went through these fast, and if they make your head spin, you can imagine how your students would feel thinking about, I know there's a part, there's a whole, a percent, I have to figure out which one's missing, and then I have to remember which procedure to use, and then I have to apply it correctly. And it's overwhelming. So, and there are a lot of other approaches you can take. There are tricks, there are mnemonics, there are strategies. But when you have tricks and mnemonics, these are kind of short-term solutions. They don't tend to stick with people. They don't tend to be transferable to real life. The percent proportion is another one that a lot of people use. So what I want to do today is I want to talk about how we can reason about percents more conceptually, more visually, and more numerically. So yeah, so not so much following a procedure, not so much worrying about which procedure am I supposed to be doing, and then trying to figure out how to do or remember how to do that procedure. And the thing is that I know some people like pictures and some people don't, but in terms of thinking about percents visually, I feel pretty confident that most of us are already accustomed to thinking about percents visually, because this is a picture that's familiar to almost everybody, right? And this is a visual picture of percents. And what I'd like you to do now, I'm going to give you another couple minutes here, is look at these 2 cell phone batteries and give me your estimate of what percent is left in each battery. And also tell me not just what your estimate is, but how did you arrive at that estimate? And you can put your ideas in the chat. So maybe the red one is 10% because it's red, yeah? A lot of different ideas, yeah. Okay. So I see some mention of dividing the battery into fourths. Thinking about 1/8 and 7/8. So thinking about something, a yard of fabric that you're already familiar with. Thinking about dividing into tenths, thinking about dividing into fifths. Really interesting how much fraction thinking is coming up when we're talking about percents. Taking half to see where that is. we're not all in agreement, and that's reasonable. Put my finger on the screen to see how many reds there are in the whole. Okay. Using a ruler and measuring. Yep. I like this answer. The first one is enough and the second is not enough. So that's also part of being numerate, is how precise do you need to be, and being as precise as you need to be in the moment, in the context. And it might be that as precise as you need to be is enough or not enough. Yeah. Okay, so one thing I want to point out is that a lot of us are using benchmarks. So we are picking up on fractions like a half and a fourth that we're familiar with, that we know how to reason with, and we know what they look like, and comparing what we see to those fractions. Yeah, so here we have fold it in half to find a half, and then you could use the half to find a fourth and see if you have the piece that's left is greater than or smaller than a fourth. So when we think about percents that we're familiar with or fractions that we're familiar with, this can help us get a handle on a situation. So if we go back to our idea about, or a task about the question, so about the shirt and the coupon, the task actually that didn't have a question. Let's think about how we could reason about this with benchmarks. How could we reason about this with a visual? Because having benchmarks is a really big part of being numerate. That's really important to have these percents that we're comfortable with, that we know how to reason with. And the first benchmark that most of us would start with is benchmark 50%, thinking about 50%. So if we look at the total cost of our shirt, let's consider that as the battery, the total amount in the battery. And I know this question is not about a 50% off coupon, it's about a 30% off coupon. But if we start to think about 50%, that can help us start to reason about it, because we know that 50% is 1/2. And so we can break our total cost into 2 equal pieces, and then each block will be 50%. And that tells us something about the situation. We have, it gives us a sort of a handle on the situation, because we know that 50% is $20. We're only saving 30%. So a 50% savings would be $20 off. We now know that we're saving less than $20. And that is a handle on the situation. It's not an exact answer. It may even not be precise enough. It depends on the person and the situation and the shirt and how much money they have, all kinds of things. But it might be enough on a test to eliminate a couple answer choices. And it might be enough in real life to start to make a decision about whether or not to buy this shirt. And that's part of numeracy, using mathematical reasoning to evaluate information and to make decisions. And 50% is something that almost anybody can get a handle on. That's the beginning of reasoning about percents. But we can also take it further, and we saw this already with the batteries. Some people were using a benchmark of 25%. 25% is half of 50%. There's a relationship there. It's a half of a half. So if we take each of our blocks, each of our 2 blocks that were each half, and cut them in half, then we'll have blocks that are 25%. So if 50% was $20, 25% is half of that, which is $10. And 25% is not really that far from our 30% discount. So now, just by thinking about half and half of a half, we know that a 25% discount would be $10 off. And with the coupon, we're saving a little bit more than that. So this gives us even a better handle on the situation. But I also saw, actually, in how some people reasoned about this, that some people were going to 10%. Some people were using 10% as a benchmark because 10% has a nice correlation or a nice relationship with 30%. It takes 3 blocks of 10% to get 30%. So we could also look at 10%. And 10% is 1/10. And how do you know that 10% is 1/10? How do you know that you can find 10% of something by dividing it into 10 equal pieces or dividing it by 10? It's not because your teacher told you that 10% is 1/10. It's because you can figure it out yourself. It's not something you need to memorize, because you can, if you want to know how many 10% there are in the whole in 100%, you can count 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%, 90%, 100%. So I can see if I put 10% on each of my fingers, it takes 10 groups of 10% to make the whole. And here, just like I was counting up to 100%, I can count up to 30% by 10%, 10%, 20%, 30%. So that gives me that 3 blocks gives me my 30%. 30% discount is 3 blocks. That's $12. Now I have an exact answer. So reasoning with benchmark 10% gets us to an exact answer in this particular case. Benchmarks 50% and 25% also helped us reason and estimate. So something for you to think about then that's important is, and for your students as well, what are your benchmarks? And I have your in italics here because benchmarks are personal. So most of us start with understanding 100% and 50%. We also, in this example, looked at 25% and 10%. But which benchmarks, which percents are friendly to you, which ones you find accessible and easy to use, that's going to depend on your own experience, your own preferences, how much time you spend reasoning with percents. And some of the percents you're going to find are friendly, and other ones are going to be less friendly to you. So, but the thing is about reasoning with percents, reasoning with benchmarks, and reasoning flexibly is that you can use the ones that you are friendly with to help you analyze or reason about the ones that you are less friendly with. And the more that you work with benchmarks, the more that you approach these kinds of percent tasks visually and conceptually, the more friends you're going to make among the percents. You will have more and more friends in percent land. And as you make friends, you're going to make friends because they are friends of your friends. They are related to the ones you already know. So the reason we can reason easily with 25% is because we already are friends with 50%. So there's a big difference between memorizing that 25% is equivalent to 1/4, which is something somebody could tell you and you can memorize, and understanding that there's a relationship between 25% and 50%, between 25% and 100%, or the whole. Because when you understand relationships, this is really important. When you understand relationships, you don't have to memorize them. And memorizing is a big strain on your mental resources. There's always a limit to how much you can memorize. Things fall out of your head, especially if they're not meaningful to you. But understanding is not a strain on your mental resources, and you can continue to grow your understanding. And so just like your understanding, your benchmarks also will grow with time and experience. We start out with 100%, 0%, 50%. It's pretty natural to move from there into thinking about 25% and 75%. And then from there, well, you could go in a lot of different places. So you can go to 10%, 20%, 5%, 33% is a benchmark for some people, not for others. And if you're worried, if you're looking at these and you're feeling worried, what if I need to find 37.5%? What if I need 63%? Who's going to have a benchmark of 63%? Well, one thing I could say is that if your set of benchmarks grows to include 10% and 5%, there isn't really any percent that you could be looking for that's going to be very far away from any of those. So if your purpose is just to get close enough, or you just need to estimate, 63%, if you can find 60% and 65%, that's going to give you a pretty good handle on 63%. And if you want to get even more precise, there's another benchmark you can learn to use through building conceptual understanding about it, which is 1%. If you make friends with 1%, you're going to be able to figure out anything. And I will, a little later, I'll share a resource that goes into a little more detail about using 1% as a benchmark. Just looking in the chat, you folks are very vocal, which is great. Yeah, memorizing a method doesn't necessarily allow you to build into more complex real world tasks. Yeah, that's a really good point, because that is, you know, we're talking about numeracy. We're talking about a lot more than knowing what to do to be able to pick the right the right answer choice on a standardized test. Okay, so let's do some work with benchmarks. Let's actually practice using our benchmarks and our visual models to reason about some real world. This is a real world percent scenario. I got an email from my credit card company, and it said I could get 20% cash back at the pharmacy, up to a maximum of $5 back. So I guess if this had been you, if you had gotten this notification, what would you want to know? What questions do you have from this scenario? Okay, how much can I spend and still get a benefit? How much do I have to spend so that I'll get the $5 maximum? Yeah. How much do I have to spend to get the $5? I mean, that's the kind of the big question here, right? Because once I've spent, there's some amount that if I spend, I get $5 back. Can I keep coming back if this is for one transaction? Yeah, so I'll answer that. This was overall, like, I'll keep spending money at the pharmacy, and I will keep getting 20% cash back, but that will max out at $5. And as soon as I've hit that $5, then I'm not getting my cash back anymore. So yeah, okay, these are good questions. Do I get the $5 or is it credit in my account? Yeah, so there's a lot, because it's in real world, in real life, there are more things we want to think about than just whatever question is asked us. But I would like to know, how much money do I need to spend to get that $5 cash back? Because beyond that, I don't care that much. I'll spend my money somewhere else. You know, if I spend more than that, I'm still not going to get any more than $5 back. So in other words, I know that $5 is 20% of something, and I want to know, what is it 20% of? I would like to know how much money $5 is 20% of. So let's look at a picture. So there's a picture. Here I'm thinking about, I have $5, and that's 20% of some amount of money. So the battery is the total amount of what I'd need to spend, and the green block is my 20% of what I'd need to spend. But I don't know. I mean, it's not really about a battery anymore. We can get rid of that. I think that was just sort of our way into it, because what we're really looking at here is a bar model. You might also have heard it called a tape diagram or a Singapore strip diagram, but it's a way of visualizing quantities and relationships, and it's a model that I'm a big fan of. So if 20% is not in the realm of your benchmarks, then you might use 10%, or you might use 25% to estimate. But for the purpose of this exercise, I'm going to use 20% as a benchmark, because I know, for me, it's one of my benchmarks. 20% is the same as 1/5. And the reason I know that 20% is the same as 1/5 is because I can count by 20% to 100%. 20%, 30%, 40%, 50%. That's not how you count by 20%. Let me do that again. 20%, 40%, 60%, 80%, 100%. It's funny that I got it to 3 fingers before I realized that I wasn't counting by 20%, but I knew where it was going. So So I know it takes 5 blocks of 20% to make 100%. So if I split my model into 5 equal pieces, then my 20% is one piece of them. Yeah, 20% is 1/5 of 100%. So I see some people are starting to get the answer starting to come to you, right? It's the answer starting to flow into the chat just from thinking about these relationships, just from thinking about how these quantities are related. Because my green block, remember, my 20% is worth $5. And because I made all of my blocks the same size, they're all worth $5. So now I can see right in front of me. So one of the things I love about bar models is once you've got them filled in, you can see the whole task. You can see the whole situation. I can see that I would need to spend $25. And if I spend more than $25, it doesn't really matter at that point. I'm not getting any more cash back because I will have maxed out my cash back. Okay, so let's look at another one. Let's look at another example of putting our benchmarks to work. So here's another one. I have 5 lesson plans to write for next week, and I've done 3 of them so far. So again, I'll ask you, what are you interested in knowing? What would you like to know about this situation? How much time did I spend writing those lesson plans? How many do I have left? How long does it take? Am I more than halfway done? Yeah. Yeah. Could I work somewhere where I don't have to write lesson plans? Yeah. What fraction of the plans is left? What percent do I still need to write? Sure. Could I write them in Spanish? I'm working on that someday. What fraction of the work is left to be done? Yeah. Okay. So let's say I want to know what percent of my lesson plans I have left to write, or what percent I have already written. Just based on our early benchmarks, using benchmark, say 50% or 25%, could you estimate how many or what percent of my lesson plans I've already written, or what percent I have left to write? So you could use 10% as a benchmark. Yep. What if you were just had 50% as a benchmark? Could you estimate with that? So you could say over half are done. Yeah, more than 50% done, which again is a handle on the situation. We have some idea of what's going on here. Yeah, if I have 5 to write, then half would be 2.5. So if I've done 3, I've done more than half. I could also estimate with my benchmarks of 25% or my benchmarks of quarters, because I know that 3 lesson plans out of 4 would be 75%. So I'd be 75% done if I only had 4 to write, but I have 5 to write, which means I'm less than 75% done. So even just with benchmarks 50% and 25%, I can get a pretty good handle on what percent I've done and what percent I have left. But if I want to visualize this, then what I need is a model that's going to show me the 3 lesson plans I've done as a fraction of the lesson plans that I have to do all together. So when I've drawn the bar model, it makes it so much easier to see the relationships and to make sense of what's going on. Drawing the bar model can be actually the toughest part of this, and I'm going to talk a little bit more about that later. But to start, I'm giving you the model, and when you see it, you might recognize it, because in the last one, we used a benchmark of 20%, and that was 5 blocks. So if you know that 20% is 1/5, then you can count again 20, 40, 60%. I did it right that time. That I have 60% of them done, and I could count 20, 40% for how many, what percent is left. Yeah, I know. So a lot of folks are saying that maybe a bigger concern is how much time I have to spend on lesson plans. And the idea that each lesson plan would take me the same amount of time to write is an absurd idea. But I was trying to keep things simple here and just talk about the percentage of lesson plans I have to write, or the ones, or the percentage of lesson plans I have already written. But if I didn't have 20% as a benchmark, but I still know I need 5 equal groups, I could try playing around with some of my other benchmarks and try to find one that would let me make 5 equal groups. For example, I might use my benchmark 10% and divide into 10 equal parts, and then I can take those 10 equal parts and divide them into 5 equal groups. And again, I can count 10, 20, 30, 40, 50, 60% done. Yeah, absolutely. I finished 60% of the lesson, and it doesn't mean 60% of the time. So actually, when we use percents to estimate, and I do this all the time, if I've got a big task to do, I estimate what percent of it I've done, and that to get some idea of how much I have left to do. But I always have to keep in mind that I don't always work at the same pace through different parts of the task. So that is also part of being numerate, is digging into, is this information relevant to me? Is this information useful to me to know what percentage of lesson plans I've done? Or would it be more useful to figure out a way to measure the percentage of time? Yeah. Also, another thing that might be on your mind is what happens when the numbers are less friendly. I mean, 3 out of 5, that was a pretty accessible, pretty friendly situation. And you notice I didn't take on the more complicated question of time. I kept with some friendly numbers. And I know that, and I've heard this from students too, well, you gave me easy numbers. I can do it when the numbers are easy, but what am I going to do when the numbers are difficult, when the numbers are complicated? And my advice is that we spend a lot of time with the friendly numbers, and we let them teach us about the structure of the situation. We let them teach us about how things work. And we don't, at the beginning, panic about not knowing exactly what we're going to do when we get to the harder numbers, when we get to the less friendly numbers. We don't want to rush through our quality thinking time just to get to a formula or a procedure. And yeah, we can use the percent proportion. Absolutely, we can use calculators, but we can still reason with visual models and benchmarks, even when the numbers are unfriendly. But what we're doing here, starting with the friendly numbers, is we're learning and we're developing intuition about how these situations work. Because when you're trying to find, for example, what percent one number is of another, what you're really asking is how big a piece of the other number it is, or what fraction it is. And you can estimate with that, or you can use a calculator to get precise answers, but you're thinking about how much of one number the other number is. And then when we're doing percents, we're figuring it out, we're turning that into hundredths. And sometimes it's going to be messy. You will want to use a calculator, but when we practice with the friendlier numbers, when we practice with our benchmarks, when we make a habit of estimating, that's how we're going to develop intuition. And then when we reach for the calculator, when the numbers are messy, we're going to have an idea of what we can do, what we should do with the calculator. Yeah. Yes. Seeing and applying patterns. Actually, absolutely. That's what we're doing here. Yeah. So speaking of finding what percent one number is of another, I just want to point out that when we found the savings on the shirt, we found a percent of a number. We used a bar model to find a percent of a number. And when we figured out how much we needed to spend at the pharmacy, we started with a percent and we figured out what the whole was. So that was one where we were missing the whole. And here we figured out what percent one number is of another. So those 3 kinds of percent problems that that we had 3 different procedures for. Drawing the bar models, it helps us see what to do for in each of those situations. We're able to address each of these situations and just kind of intuit what we can do based on what we can see in the bar model. And I know that the percent proportion does work for all of these situations as well, but we are seeing that there are things that are confusing there because we have some vocabulary we have to learn in the percent proportion. We have to know part, whole, and percent. And it's confusing to distinguish between part and percent. So writing out the word percent is a solution, but what I love about the bar model is that what's the part and what's the whole and what's the percent, it's all visually there in front of you, and you don't need to worry about what the labels are. Okay. So let me show you now. I'll take a little detour into why it's so useful to know our benchmarks and to be numerate about percents. Because this is an ad that I saw on television, and it went by pretty quickly, but in this day and age we can pause our television, and I paused it and I went back and I took a picture of it because I thought I saw this percent come up on the screen and I wanted to know, was this accurate? Was this picture I was looking at reasonable, or was I maybe being manipulated? And because that's part of being numerate as well. It's about being able to make sense of quantitative information. And I looked at these 2 stacks of paper and I wondered, is this second stack of paper 65% taller than the first stack of paper, the one over here, the short stack? Because it sounds pretty impressive. That's a pretty impressive claim, 65% more pages than Bargain Inks. Although actually it's up to 65% more, so we may not even get that much. But how can I estimate? How can I get an idea using my benchmarks of whether this second stack is reasonably 65% more? Yeah, so I see some folks in the chat are saying it looks like it's about 3 times as tall, that second stack. And 3 times as tall is definitely more than 65% more. But just to be sure, let me, I'll use my benchmarks. I'll use my visual to reason about this. So I'm going to start with a bar that's going to be the height of the first stack. And I will put in my 25% benchmarks, 25%, 50%, 75%. And because I'm dealing with 65%, and 65% is more than 50%, but less than 75%, a little bit closer to 75%. So that yellow piece there is showing me about how high 65% of that shorter stack would be. So if I put that on top, I can get an idea of how high that second stack should be if it were really showing 65% more. But that stack is, yeah, it's definitely more than twice as big as the first stack. So that's a lot more than 65%. In fact, twice as big is 100% more. That's doubling. 65% is less than doubling. And it's very easy to be taken in by something like this if you don't take the time to think about what does 65% really mean. It may still be worth it to spend the money on ink that's promising up to 65% more, but yeah, visuals don't lie, but you can lie with visuals for sure. Yeah. Okay, so what I want to do now is I want to get to how we can put all this together and bring it to our students. Because one of the things I said before, the thing that can be the most challenging about bar models is drawing them. That's the thing that that students have struggled with in my experience, because I really love bar models, and I brought them to my students, and I expected them to fall in love with them as well. And They did not. They did not fall in love right away. It took them longer to fall in love with bar models than it took me. And in fact, when I started, when I jumped right in originally with asking them to draw them themselves, my exit tickets came back saying, I hate bar models. And that is not what I wanted for my students. So, so I worked on finding a way to scaffold this a little bit more, because ultimately I want my students to be able to draw their own bar models, but that's a bit too much of a leap, or it was for my students as a place to start. So I'll show you what I did, and I'm going to give you at the end of this a packet that you can take away that has a lot of examples of percent tasks that you can reason about with bar models. But I'm going to show you now how these tasks are set up. So so here's an example of a task, and again, like my other ones, there's no question in it. I want to keep this open so that we can think about how much information can we extract really from this scenario. Altogether, how much information can we extract? Because if we are encountering this in the real world, then there might be a lot of different questions that we want to answer. And if a student is encountering this on the test, if they're accustomed to extracting all the information they can, they're going to be able to then identify which piece of information answers the question. And they're not going to have that panic moment of trying to remember what procedure they're supposed to do and grab for some procedure, the first one that presents itself, just do something on the calculator and pick an answer, because you know that those answer choices will have the results of applying the wrong procedure to them. So so yeah, so you might be asking how many people like spring, for example. That's one of the questions I see. So we've got some answers coming in already, even though there's no question. But so what I've done first for the students, though, is I've presented them with a choice of bar models. So I don't want to do all the work for them of creating the model, but it was too much of a leap for them to create it themselves. So this was the middle ground that I found, which is to offer them several bar models to choose from. So so yeah, you folks are coming up with a lot of answers, and I'm going to give you in a minute a place to put those answers. But first, I'm curious, which model of these four would you use to reason about this task? The first one, so the one at the top left here. Yeah. Okay. It's pretty popular. Yeah. Okay. Maybe none of them. Sure. You don't have to use these. So I did see go by, somebody said maybe we could use the one on the top right, because that one also has 4 blocks. So also could be used to reason about 25%. We could consider that the 25% who said spring was their favorite season was this gray block over here. So one thing to know about this packet is that sometimes there's more than one model that will work. But as long as students can pick a model that makes sense to them as a way of visualizing the situation, there's more than one possible answer here. Okay. Yeah, and this is it's a nice long packet, by the way, and you can also do you can create more. I mean, you can take any of your you know, your standard percent tasks off of a worksheet or out of a textbook, and you can modify them into this kind of task. So so in addition to the 4 models to choose from, I've also given the students a table to organize their information. And I want to be clear here that the task is not to fill in the table. That's not the goal. The table is a tool. It's a tool to help students make sense of the scenario and extract information from it, not the end, not the goal of the problem, or not the goal of the task. So what I can do to fill in this table is I can start by looking at the information that was given. 80 people were surveyed to start with. And I'm going to look at, I have a column for number of people. So that's where I'm going to put the numbers that are the raw numbers of people. And there were 80 people surveyed total. So I will put that, there it is, in the table. And the other information that I have is that 25% of them said that spring was their favorite season. So I have people who said that spring was their favorite season, people who did not say that spring was their favorite season. I'll fill in 25% as the percent of people who said that spring was their favorite season. Okay, now I see in the chat a lot of other information coming through. I've seen the number 20 coming up, and so I know. Let's see. I've seen some people say that 20 is the number of people who chose spring as their favorite season. Can somebody explain how we know that? Half of a half, right? Yeah, that's a nice way of doing it. So if we think about 25% in relationship to 50%, we could have taken half of 80, which is 40, and half again. Or we could think of 25% as 1/4 and divide 80 by 4. So that means actually that we also know something about the fraction. So we might say that that was 1/4 of the people. Or another way that you might fill in this fraction cell is you might think of this as 20/80ths of the people, 20 people out of 80. And it's going to depend on your comfort with fractions and the order in which you're thinking about the different elements. So how you write the fraction and how it's useful for you to write the fraction. And ultimately, it's useful for students to see that the fraction is 20 people out of 80. That's good information. And also that is 1/4 of the people. Okay, so if they have a total of 80, the first diagram will be each block is 20. So 1 out of 4 blocks. Yep. Or 25 out of 100. Yeah, we could write 25 out of 100 as well, because 25% is 25 out of 100, and we know that that's 25%. So it's not that there's only one thing you could write here in this box in the table. And I also saw, well, let's fill in the rest of this. I think I've seen almost every answer go by in the chat. That we had 60 people who were not in favor of spring, and if we or wasn't their favorite season rather, and we can see that as maybe that's the rest of the people. There were 20 people who said spring was their favorite, so 80 minus 20 is 60. Or we could consider that that's the other 3 blocks, 20, 40, 60. And for the fraction of people who preferred some other season, how might we write that fraction? What fraction might we put there? Yeah, 3 out of 4 is a good number to put there. We could also put 60 out of 80. We could put 75 out of 100. Lots of possible answers. In this cell here, the total fraction of the people, this is a cell that's worth filling in. And you might find that students might fill it in different ways. Some students might fill it in as 4 out of 4. You might fill it in as 80 out of 80. You might fill it in as the whole. A lot of different ways to think about this, but it's good to make all of those connections. And I think I've seen also folks putting in the answers to these last couple cells, but they all sort of come in differently, right? They all come in, or the order that they come in depends on how you think about it. But if we know, well, here, let me go down to the bottom and say that we know that the total, this is a non-trivial thing, but that the total is 100%. And it's something that's worth making sure that we all understand, making sure that students understand. And so then if 25% said that spring was their favorite season, then we had 75% who who chose something else or who did not say that spring was their favorite season. So, so we have a packet that has a lot of different problems like this, a lot of different tasks like this that have different levels of benchmarks. You might want to, pull them apart and decide which ones are appropriate for your students, but I'm going to share with you where you can find that packet and a really detailed answer key as well. So let me go through a few resources for you. Get to the next slide. Whoops. Okay, here we go. So I'm going to start with the packet, which is, and where you can find this, and there will be a copy of this slideshow available to you, so this link will be active and clickable. The packet is called Modeling Benchmark Percents and Fractions, and you'll find it hosted at the website for the Sabe Center for Math and Numeracy, which is our adult education professional development organization here in Massachusetts. I'm also going to give you a link to a blog post that I wrote at the blog for the Adult Numeracy Center, also here in Massachusetts, and it's called How I Learned to Stop Worrying and Love Percents. And that blog will go through some of the same ideas that we've talked about today, and also give you an example of using 1% as a benchmark. And also, so I just want to say that sort of sitting quietly in the corner this whole time, I know I talked about the Adult Numeracy Network at the beginning, and it's been sitting there not making trouble in the corner this whole time. But I want to say that if this is your kind of math, like if you are into numeracy, then this is the place to go. This is your one-stop shop for everything numeracy, and this is your community. This is your community of numeracy educators. So please do check out the website, and please do join our network and become one of the heroes of adult numeracy. I will also give you here, this is my contact information if you want to reach out to me personally. And as I said, this will all be available in the slideshow that will be shared. And one more thing I want to say that's important before I turn this back over to James is that if you are going to be at COABE in Atlanta, the Adult Numeracy Network is putting on a pre-conference session. It is called Elevate Student Agency with Mathematical Play. It's going to be super, super fun and super educational. And if you're going to be in Atlanta, I really encourage you to join us. And you can find the information to register. You can register at the COABE website, or you can go to the Adult Numeracy Network website and register there. And I did see, so there was a question about no, I did actually do this in PowerPoint. So if you want to chat more about PowerPoint and how to present math in PowerPoint, you're welcome to reach out to me. So, all right, thank you so much, everybody. I'm going to turn it over to James, but I'll be here for a few more minutes if you have other questions.
Sarah, thank you so much. That was an awesome presentation. I love how interactive it was, and very good, excellent information. I want to thank everybody for attending today. If you could take a minute to fill out our one question poll before you log off, that would be greatly appreciated. As a reminder, a replay of this with all the materials will be posted to coabe.org within about 24 hours of the completion of today's webinar. So you can access it again. And for those of you who registered but weren't able to attend, it'll be available for you as well. So once again, thank you everybody for attending. Thank you, Sarah, for a wonderful presentation. Hope everybody has a great rest of the day and a great rest of the week. Thank you so much.
Thanks, everyone.
Bye-bye.